Welcome back, nerds, to Trigonometric Equations and Inequalities. Today we are going to finish up equations and move on to inequalities. But before we do move to inequalities, because that's what's on the next page, before we move to inequalities, after I do this question here, I am going to do a question from the homework set that I did not assign, and I'm going to suggest that you do it with me. That way you have at least taken notes on a question like that. Okay? I'm going to be helping you. I'm going to do on camera question number 18 from set B or set 2 or whatever it is. Okay? I think I assigned 16 and 17. I'm going to do 18. So that way you see it happen. Cool? All right. Great. Beforehand, let's do this one. Yesterday we finished up this solving a trig equation by making a substitution in the argument. And the reason why we did that is because, well, how do you figure out with this double angle or this, half of a period, how many times you're going to have solutions and where they're going to happen? Well, the easier thing to do is to just say, well, I'm used to tangent of theta or tangent of x or whatever. A nice, clean, pretty simple argument. But if you make a substitution for the variable in the function, you have to make the same substitution in the variable for the domain, which is how we went from 0 to 2 pi for x up to 0 to 4 pi for theta. Essentially, which I didn't write it yesterday, but essentially what we did to get from here to here was we doubled everything. That way we could see the 2x and make the exact same substitution that we made in the function. We're going to use that exact same trick where we manipulate the argument and the domain to figure out where sine of x over 3 equals 1/2. Okay? So let's see. Trying to figure out what color I want to write in. I guess I'll go with purple. Here's what we're going to do. We are going to let the argument of x over 3 equal something easier to work with. We're going to let it be theta. So now it doesn't say sine of x over 3, which is difficult. What it actually says is sine of theta equals 1. Our domain, which was from 0 to 2 pi, not including 2 pi, we need to do the exact same thing that we did here. That means I need this x to, hold on. Yes? What's up? Did I make a mistake? Oh, it's just 1 over 2? Oh, oops, there. I need this x to say x over 3. So essentially what I'm going to have to do is I'm going to have to distribute a 1/3 to this domain. When I do, I will get my domain goes from 0 to 2 pi over 3. And now I can make the same substitution. So for sine of theta equals 1/2, I have to exist only between 0 and 2 pi over 3. Like that. In which two quadrants will sine be positive? Quadrants 1 and 2. So I know that sine of theta can equal 1/2 in quadrants 1 and 2. So I'm going to draw them both. Picture not drawn to scale. It never is. Sine is y over r. So that's giving me y values of positive 1 and radii of 2. What are the x values then? Root 3s. These are clearly 30, 60, 90 triangles. And of those three numbers, 30, 60, 90, which one is going to be across from the 1? What's the size of my reference angle? 30 degrees. But in radians, what is 30 degrees? Pi over 6. Cool. Okay, so if it's pi over 6, then this first answer is clearly pi over 6, right? But what's the second answer then? It's 5 pi over 6, yeah, because it's a pi over 6 before pi. It's 5 pi over 6 But my domain only goes to 2 pi over 3, which, by the way, if you use common denominators, is 4 pi over 6. That means I had to stop looking for answers somewhere around there. So there's only one solution. This one. Because that one is a pi over 6 after the end of my domain. So we get theta equals pi over 6. But remember, we're not solving for theta, we're solving for x. So we get to do like an unsubstitution. We know that theta was actually x over 3. So yep, you just multiply everything by 3. And what you get is x equals 3 pi over 6, which is pi over 2. That is the only solution. And I checked it on Desmos. It's right. There is only one solution in the first 2 pi. But if you think about it, it should make sense. Because the period length of this function is 6 pi. It takes a full 6 pi before it completes one cycle. That means the first half of the wave takes 3 pi's. So you weren't ever going to get to that second time that it equaled, because that would have happened between 3 pi and 6 pi. And that's why there's only one solution. And I hope that makes sense what I described graphically and didn't show. Yeah? Okay. Can you do that for all of them? Well, I mean, you can if you're trying to figure out where they stop or to try to make sense of why they don't have more answers. I don't like to do that. I like to use that knowledge of transformations on the argument to help me confirm my answers rather than find my answers, because I'm such a highly visual person. I really do need the shape. I have to. With curly cues and stuff like I did yesterday, I struggle without it. And I told you I was going to do number 18 from set B in the homework, right? All right, let me grab it. Yeah, it has a phase shift and a horizontal dilation, which we don't have any of our notes like that, but I did assign one in the homework. I assigned number 17. So number 17 has a phase shift and a dilation. So I'm going to do number 18 that way that you see one done. Okay? Now, space is going to be at a premium. I'm going to have to write small. Also, I don't know if you caught this, but in the directions, we are going from 0 to 2 pi, but in the directions, 2 pi is included. Did you see that? Where in the notes, it wasn't. So it doesn't change the answers for this question. I just thought that that was funny. So we know that our domain is going to go, so because space is so tight, I'm going to actually start writing up here. And this function, instead of being in terms of x, is in terms of thetas. So I'll be using x as my substitution. We're going to let x equal 3 pi plus pi over 3 theta, excuse me, plus pi over 6. Gosh darn phone. Okay, interruption's over. Anyway, there. I'm making that substitution for x. And for theta. If I make that substitution in the function, I had to make the same substitution in my argument of in my domain up there. That means I need my domain to say 3 theta plus pi over 6. So how do I make that happen? What do I have to do first? We have to triple everything first. So you're going to triple everything. Now it says 0 is less than or equal to 3 theta is less than or equal to 6 pi. And I needed to say 3 theta plus pi over 6. So you just add pi over 6 to all three things. So the domain that x is going to operate on will be pi over 6 to 6 pi plus pi over 6. And 3 theta plus pi over 6 is x. So I just saved myself a line since space is at a premium. Okay? Okay. We are attempting to figure out where sine of x now equals 1 on this domain. So first, I'm going to draw my quadrants. And let me ask you, for y over r, where is the only place that the y value is same as the radius? The y-axis, specifically the positive y-axis. This will be the only place where y equals 1 and r equals 1, where sine of x equals 1. And this is variable x, not coordinate x, okay? Which is what, pi over 2? How often will that answer repeat itself for sine of x? How long is the period then? Every 2 pi. So we know this answer repeats itself every 2 pi. I'm going to draw the curly Q thing just so I can see how many answers I need. Ready? First, I'm going to start at pi over 6. So allow me to draw a dotted line for pi over 6. That's a 30-degree angle. And now I'm going to go from there to here. And by the way, this is 3 circles past this green line. So it's going to look like this. There's 1 circle. There's 2 circles. There's 3 circles. I hope you can see that my purple curly Q deal hit this angle 3 times. So we have to say the first one's pi over 2. And then we have 2 more, and we know that each time is just 1 period of this away from the last, right? So we have answers of x equals, we knew the first one was pi over 2. And in case you don't remember, 2 pi is 4 pi over 2. So we just add 2 pi, which means we just add 4 to the denominator. 5 pi over 2 and 9 pi over 2. But of course, that's for x, right? And we need to solve for theta. So attempting to get theta by itself, what are you going to do first? Subtract pi over 6. Oh gosh, okay. That means I need all these things in terms of sixths, so they have common denominators. What a pain in the keister. Fine, I'm going to triple the top and bottom of all of these fractions. That way they all say over 6. So I have 3 pi over 6, comma, 15 pi over 6, comma, 27 pi over 6. Now I can subtract 1 pi over 6 from every one of them. So I'll have 2 pi over 6, 14 pi over 6, 26 pi over 6. And all 3 of those reduce. What a pain in the rump, right? All 3 of them reduce. So I have a pi over 3, a 7 pi over 3, a 13 pi over 3. And lastly, how do I get theta alone? Divide by 3, which is the same as multiplying by 1/3, which is just going to triple the denominators of these right here. So what we get finally is theta equals pi ninths, so pi over 9, 7 pi over 9, and 13 pi over 9. So now you can see what you have to do when there is both a phase shift and a horizontal dilation. I will never say that they're easy. Those are challenging questions. There's a lot to them. He says it's insane. And actually, that was a kind one. It was kind because it was only 3 answers instead of 6 or more. Because what if it had been a plus or minus 1/2? Then there would have been 3 answers here, 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 and here, and there would have been 12 solutions. And I've seen that done before. I do it in IB and when this was a pre-calc honors course. I gave them a test and there was 8 solutions to a trig question. Yep. What's that?
You said
I said trig, not trick, sorry. A trig question like this, but it had 8 solutions. Okay, there. Now you've seen the worst of the worst, so to speak, when it comes to solving equations, yes? Now we can move on to solving inequalities. Unless you have questions for me on this one, or even the one that I just did in the homework. We good? Okay. Remember what I said, don't put too much stock into the answer key for the homework online. Don't immediately think that you've screwed something up. Check Desmos first with your answers to see if you were right or not, because we already know of one for a fact that was missing a correct answer. So just don't spaz, check Desmos, and if you're wrong after that, then shoot me a message, and then I guess you can start to spaz. So trigonometric inequalities are usually going to require you to use graphing technology, but not always. So here's your warning. Be able to do it by hand when it's possible. That's the best I could say. For example, this one we can do by hand and we do not need a graphing calculator because you should be able to graph y equals cosine of 2x. And you should be able to easily see where that graph hits the x-axis. Yes? Which is its midline. Okay? Now, if it was something ridiculous like the number 1/3 or something like that, which is not ever going to arise from a special right triangle, then yeah, you would need to use graphing technology. But if it's going to hit a maximum, a minimum, or a midline, I expect you to be able to do it by hand. Cool? Just know that your Unit 3 test that you'll take after the AP exam will have a calculator portion and a non-calculator portion, and a question like this is fair game on no calculator portion. A question like this would be mean on no calculator portion. So that I'm going to use a graphing calculator for. But let's do this one. So we're going to graph cosine of 2x. First, we need to know its period. Well, we're only going to go from 0 to 2 pi, but we do need to know the period of cosine of 2x. Yep, it will be pi because the period is 2 pi over b, and our b value happens to be 2. So this cosine wave is going to repeat its values every pi. That means in the first 2 pi's, I'll have 2 complete cycles. So here, I'm just throwing a 2 pi out there on the x-axis somewhere. Halfway between 0 and 2 pi is going to be where you find 1 pi. Feels like it's right about there-ish. And since the period length is pi, I need to divide my pi's into fourths. So there's halves, and then fourths. Are those legible? Can you all read all of those increments? Okay. I tried to make them larger than I did in second period because I knew some people were struggling to see it. The 1 and -1, really not all that important because we're just looking for midline hit. This is a positive cosine wave. Where does it start? At 0, and will it be a midline, a maximum, or a minimum? Maximum. So positive cosine begins at a maximum, and 0 makes the end side equal 0. So we're going to begin at 0, 1. Since pi is the period length, it's going to happen there again. Halfway between my 2 maximums will be my minimum, and halfway between my mins and maxes will be my midline hits. Wash, rinse, repeat. And then connect your dots. We are hunting for where this thing is greater than 0. So that's going to be this zone, and that zone. It does not say or equal to 0, which means when my cosine wave is on its midline, that is not part of my solution set. So our solutions are bracket on the 0, And we stop being above the x-axis right here at pi over 4. Then we begin being above the x-axis once again at 3 pi over 4. But the fun ends at 5 pi over 4. Picks back up one more time at 7 pi over 4. And since 2 pi is not included in my domain, parenthesis. Not bad, right? That was not too bad. Because 0 is an obvious thing. We even could have done any of the ones where they hit our special right triangles. I mean, I could have said, where was it greater than 1/2, or greater than root 3 over 2, or greater than 1 over root 2? You know? I could have said any of that. Or even the negative versions of those. Because you can do all of those by hand. Because you can tell me where cosine of 2x equals 0. That's not bad, right? The issue, though, is questions like that. Do you know where a shifted sine wave is equal to a non-shifted sine wave? Yes, got a question for me?
2 pi be included?
On this one?
Yeah.
No, because 2 pi has a parenthesis on the domain. If it was included, then yes. So you just want to watch the directions. So here's what's up. Because we don't instantly see where these things are going to be equal to each other, we're going to use our graphing calculator. Is it possible to do it by hand? Yes, it is. But it requires you to know an identity that you don't know how to do yet. We call them the sum or difference identities, which is how to write this in terms of sine and cosine. There is a way of doing it. You just don't know it yet. I am going to graph them, though. I'm going to graph them by hand, and what I'm going to do is I'm going to use graphing technology to figure out where they intersect. How about that? Okay? My scale is going to be a little strange, though, because the period for both of these is 2 pi, right? But this has been shifted to the right, pi over 3. So normally my 2 pi's, I break them into 4 pieces, which means my scale would be pi over 2's, right? But then this thing is going to be shifted over by 3's. Sixths. 12s would work, but sixths would be better because that's the common denominator between the thirds and the halves that this was going to show me. Okay? So I will use pi over 6's for everything. Cool beans? Okay. And I'm only supposed to go out to 2 pi. So here will be my 2 pi, which, by the way, would have been 12 pi over 6. I'm going to break my 2 pi in half. This would have been 6 pi over 6. I break that in half. This would be 3 pi over 6, which is pi over 2. Okay? Did I do that right? Yes. And this would have been 3 pi over 2, which is 9 pi over 6. Okay. So then I'll have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. Those are all of my sixths. Yes? So 2 pi over 6 is pi over 3. So this is 1, 2, 3, 4, 5 pi over 6. 6, 7, 8 pi over 6, which is, what's 8 pi over 6? 4 pi over 3? Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. Like that. Or did I write the wrong ones? No. So 2, 2, 2, 2. Okay, I wrote all the right ones. Use sine of x in blue. Cool with that? That one will be easy. Oh, I should probably put my 1 and my negative 1, right? Sine of x begins at its midline. And it'll end on its midline. It's got a period length of 2 pi. Halfway between 0 and 2 pi, it'll be on its midline again. Halfway between 0 and pi, it'll be at its maximum. And halfway between the 2 midlines here, it'll be at a minimum. Down there. So we've got a wave that looks like this. What this did is it took those 1, 2, 3, 4, 5 dots that I just drew and shifted them all right pi over 3, which is 2 tick marks because these were sixths. So this dot is here. This dot is here at 5 pi over 6. This dot is here at 4 pi over 3. This dot is here at 11 pi over 6. So it says, when is the green one above the blue one? I hope that it's obvious that the green one is above the blue one for all of this space. Is that cool? But the question is, where did they intersect? Now, picture not drawn to scale, but I'm not going to lie, I'm pretty darn proud of myself because it looks like my intersections hit at a perfect x scale there and a perfect x scale there. Would we trust our eyes? No. Okay, we're going to use graphing technology to find those two things. You guys cool with that? All right. Make sure your calculator is in radian mode because we don't graph in degrees. Go to y equals and type them both. So we've got sine of x minus second pi divided by 3 and sine of x. Don't hit graph. Because we're going to think smarter, not harder here, okay? Cool? What we want to do is go to Window, and we want to adjust our window so that it looks like this. We know that we're going to go from 0 to 2 pi on the x-axis. What would you like your scale to go by? What did our scale go by? It went by pi over 6s, didn't it? Now your minimums and maximums are 1 and negative 1. I just want to be able to see it on the graph, so I'm going to go from negative 2 to positive 2. Now when we hit graph, we should see this shape and that many tick marks. Ready? Everybody's cool? Everybody's had a chance to do what I did? 0 to 2 pi, we went by pi over 6s just like we did here because that was the common denominator. And I just went 2 to negative 2 because it will make it so that the whole thing fits on the graph. And I hit graph. Okay, so right now it's graphing my green wave. Oh, crap. I forgot to draw the bottom piece. Now it's graphing sine of x, which is my blue wave. Okay, I forgot to draw this. Sorry. Now, you can see that the intersection points did actually happen at a perfect x value. How would we normally find our intersections though? Do you guys remember? Second trace intersect. Here's what we can use our eyeballs to get an idea. It looks like it's happening at the 1, 2, 3, 4th pi over 6. We think it happens at 4 pi over 6. 1, 2, 3, 4. It looks like 4 pi over 6. That's 2 pi over 3, right? So what I'm going to do is I'm just going to write 2 pi over 3 because we're going to figure out what that is in a minute. And it looks like it also happens at, this was the fourth one, 5, 6, 7, 8, 9, 10 pi over 6, which is my 10th one here, which is 5 pi over 3. So you could either do second trace intersect, or since you think those are the answers, you could go to second table set. Let it start at 0, but tell it to go by pi over 3s. Because we're suspecting that 2 pi over 3 and 5 pi over 3 are going to get zeros. So I'm going to tell it to go by pi over 3s in my second table set. And then I'm going to go to second table, and I'm going to count. That's 0 pi over 3s, 1 pi over 3, 2 pi over 3. Look, they're equal to each other at 2 pi over 3. 3, 4, 5 pi over 3, they're equal to each other again. So yes, those were the 2 intersection points. Second trace intersect would have given us decimals. And what you then could have done was written down the decimals and then just done 2 pi divided by 3 on your screen on the front to make sure that it was right. But yeah, it worked out. This is 2 pi over 3. This is 5 pi over 3. Are they always going to be perfect? No. But when they are, you're happy. So yeah. You mean on the AP exam? Could you use decimals? I have no clue because we've never seen it. I'm sorry. Would I accept decimals? Well, yeah, I would, because I would expect you to do second trace intersect. But you can easily check these though to see if it's true. Look, if you put 2 pi over 3 right here and you subtract a pi over 3, it gives you pi over 3, right? Is sine of pi over 3 equal to sine of 2 pi over 3? Well, yeah, it is. Because those are the 2 over 3s that are in quadrant 1 and in quadrant 2. So sine of 2 pi over 3 does equal sine of 1 pi over 3. Because that's the triangle in quadrant 1 and the reflected one in quadrant 2. So we know it works. Anyway, our solution set is from, and since it has equal to bar, it's inclusive. There it is. Pretty cool, huh? And we have enough, this is fourth period, right? We have 9 minutes. I say we tackle example number 12. Is 1/3 any of our special right triangle ratios? Nope. So what that means is you are not going to have a choice but to use second trace intersect. You're not going to have a choice. Okay? So I'm not even, we could graph it. But just so you know, it's going to look like this. Here's your cosine wave. Notice I didn't put any numbers on it. And here is the line y equals 1. What just happened to my brain? Oh, this is cosine of x. Because what I think is much easier to do is to subtract 1/3 from both sides and do this. Because then we can do second trace intersect very easily. So I'm going to put negative 1/3 down here. And that's going to be in green, I guess. That'll look like this. And we're saying, when is my cosine wave above this number? Well, the answer will be here and here. So I just need to know, where are these two x values? What I just said, does that make sense? I subtracted 1/3 from both sides. I'm going to do y equals cosine of x. And I'm going to do y equals negative 1/3. That'll be the horizontal line. And I'm trying to figure out where my cosine wave exists above this number. So it's all of these x's and all of these x's. On y, clear, cosine of x and negative 1/3. And there's really not a reason to change the scale because we went from 0 to 2 pi, right? So I'm just going to hit graph. Boink. There's cosine x. There's negative 1/3. Second trace intersect is going to give us our two results. Second trace intersect is the number 5. Hit yes, and then scroll. Looks like it happens once at 1.911. Yes. What were you asking? You could have done cosine of x plus 1/3. Then if you wanted to do second trace intersect, you would have needed your second line to be y equals 0. Yeah, you could do that too. I'm a fan of looking where, like typing less. You know, I don't know. Doesn't really matter. But yeah, that works also. And the other answer, second trace intersect, so 5, yes, scroll. And I'm expecting, actually, I keep that to myself. Hit enter. The other one's at 4.373. Okay. So our answer set is, and by the way, both the 0 and the 2 pi are included, and the solutions themselves are included because it says equal to. So we go from 0 up to 1.911, as well as 4.373 up to 2 pi. What you think about them apples? Pretty easy? You know why you think it's easy? Because you're nerds.